I wanted to take a moment to compare some exponential functions that might look very similar to one another, but have some key differences, and those key differences lead to key differences in the graph. So we're going to start with y equals 45 times 1.03 to the x. This is a 3% increase yearly, monthly, whatever the 1 unit of time is. We anticipate an initial value of 45, which is what we have here. And we see that moderate growth from the 3%. I'm going to back this out a little bit so we can see this next one a little bit better. And let's graph 45 times 1.08 to the x power. Notice that we still have that same initial value of 0.45. That also serves at this point as an intersection of the two of them. But as these exponential functions are typically looked at for growth and decay over a period of time, we're typically looking to the right. And you can see that right out of the gate, there is a fairly significant difference between these two graphs. So right about here, let's say for the 300, the 1.08 only had to get to 24, while for 300, the 1.03 needed to get all the way to about 64, 65. So it's taking this red one a lot longer to reach those same values that the other one already reached. And if you back this out even more, you're going to realize it's just going to continually get worse and worse, and those exponential curves are going to continue to separate from one another. Let's back off those two, and let's go to a couple where decay is involved. Here we have a 3% decay, which, as you might imagine, is the reflective mirror image of a 3% increase. This is a 3% decay over every unit of time. So while this, again, starts at the point 0.45, we see a fairly rapid decrease. And by the time we're at about 200, we're already less than a tenth of whatever the quantity already was. Contrast that to our next one, which I have not brought up yet. This is actually a 56% decrease over every unit of time. And you can see how quickly that dives in relation to the 3% decrease, where it's under a tenth by the time you get to 7 or 8, as opposed to this one, which was out near 200, significantly farther out. These rates are not to be taken for granted. There's certain things that you can anticipate. You know that this first number is going to be your initial value. But if you're going to start having this conversation of what are these going to look like, you should anticipate that sudden decreases are going to look very different than these sort of smooth decreases that we walk into here. We still have that in the purple one. It still has decreases that are smooth. This is not a corner here. This is rounded off down here. But even though it's rounded off, it doesn't mean that it was decreasing slower. It means it was decreasing significantly faster. So you want to be aware when you're graphing these and thinking about what the graph should look like. You want to be aware almost before you graph. It's like when you graph a line, you know that it's going to be the shape of a line. You know these exponentials are going to take this general form of these big swooping changes over the course of time. But depending upon the number that's on the inside of the parentheses and the rate of increase or decrease that suggests, it might make it look like you're seeing a rapid decrease or a rapid increase depending on those rates.